Now that we have some idea of what collections and abstract data types are, we're going to take a look at the central topic for this chapter, which is going to be the abstract data type that is called stacks. So imagine for a moment the desk that I'm sitting at. Well, to my left, I have around a dozen textbooks for this course, other courses, various other things I'm reading. And they're all in a stack. So if I were to draw it as a picture, you might see the side of my desk looking something like this. Maybe I have a particularly big book, smaller book on top, maybe even a larger book, and maybe a small book. For the sake of having terms we can use or words we can use, let me say that this stack of books, right, has a top to it, right? The topmost book, right? The one I can see the cover for. Just the thing I can see. And underneath, of course, I have my table. Let's say I want to look at a particular book. Well, if it's the one on top, it's easy, right? I can just pull off the topmost book and read it. No problem. But notice that these books underneath, right, the second book, the third book, the fourth book, those are hard to get to, right? Normally I can't really get at those without messing with things, right? It's just the top book that is most accessible. And so this basic notion, right, of a stack of things, right, and you can only access the top and you can only add to the top, right? It's hard for me to wedge in a new book at the bottom, right? Normally I would add a new thing at the top. This general notion is what inspires the stack ADT, right? So what I've literally drawn here is a structure we can actually mimic in Java. So we'll have a data structure called a stack that behaves just like this. I can add data to the top, right? I can add stuff to the top, but I can never access the bottom, right? I add to the top and take off the top, right? I'm not allowed to do anything else. I do have the ability to add stuff back to the stack, but I can't pick an arbitrary position. I must put it on the top. Generally speaking, this is what we call a last in, first out data structure, right? This is giving me a set of rules, right, or criteria that says how I can access things, right? The last thing I put in, right, that topmost book is going to be the first thing I get back out, right? A general rule that tells me how this data structure should work. You might want to contrast this with an array. In an array, you have indices available to you, and you can basically pick, oh, I want this particular index, I want to set it to something, or I want to take it, the information out of it, right? You have your choice of what index you work at. In this case, or in the case of a stack, we can only work at the top, right? We cannot work wherever we want. We just have kind of this one side that's active, right? We can't just worm our way into the bottom and change something else out. Having said that, let's jump over to the slides to see the slightly nicer picture of this overall concept. So this is the picture in your textbook, and this one looks a lot nicer, and you can see here that this whole point of the stack is that we have a bunch of data, right, this stuff here, and this information, right, it's kind of just sitting there for us, and when we want to add something to this collection, right, this stack collection, we can only add it on the top, right? We add to the top. Then when we want to remove something from this collection, right, take out an element, we'll have to only take it from the top, right? Again, we cannot tinker around with what's underneath, right? We only work on one side. We only work on the top of the stack. Again, visualize you have that pile of books, and it's just too much trouble, right? Too problematic to remove the bottom stuff. You only want to take the thing that's on top, right? The thing you can see immediately. Now that we've talked about the concept, let's take a look at how we would actually structure this in terms of an object and some methods in Java. So over here, we have an interface, or perhaps an API being defined. One thing I guess to note is that whenever you have a collection, it's going to have methods that do roughly the same thing, and by that I mean add something, remove something, but they'll have different rules behind them. Stack, right, we said was last in, first out. There's something else called queue that we're going to see later that will have slightly different rules. But even though, right, they're both going to have rules or methods that let us add stuff, because they have different mechanics behind them, we're going to call them different things, right? So in this case, for a stack, we'll call add-in object a push operation, whereas for the other data type that we'll talk about later, queues, we'll call that a in queue. So names can be kind of different, even though they may be similar in a way, right? They both add the same. They both add elements to the collection. So in general for stack, we have these 5 different standard operations that pretty much any stack is going to implement. And I mean that in terms of not only the one we're going to be working through in the book or in the Java API, but even the stacks you'll find in other programming languages. The first one we have on here is push. So push is the one we're going to want to use when we want to add an element to the collection, right, to the stack, right? Imagine you're putting a book on the top of that stack that already exists on your desk. The opposite of that, right, is called pop. So pop, right, is us taking the item off the stack, right? It's us pulling that topmost book so that we can actually read it. We then have peek. Peek is kind of a way to preview the stack, right? So you're allowed to look at the topmost element and see what's there. But you don't actually take it off, right? You don't actually physically remove something. You just glance at it, right? Really what that's saying is you return a kind of a copy or a reference of whatever is on top, right? Whatever piece of data we're trying to store in our data structure. Our fourth one here is empty. So this one is kind of generic to a lot of collections, and this is a general method that's just going to check to see whether that stack has anything in it or not, right? So if there's 0 books, this will tell us, that it is empty, right? It lets us very easily check to see whether there's anything in there. The last one here is a little bit more specific, but again, a generic thing you'll see in a lot of collections, which is size, right? So instead of just saying, oh, is this thing empty or not, this is actually going to return to us an integer that tells us how many items are actually in that stack.